Yes, we are. Hello, everyone, and welcome to another COMPET Talks. My name is Davi, and today I'm here with Caio and Marcel. And no, their camera is not duplicated. They are twins. I just got to know this. So if you
Yes.
wonder, that's the case. And that's a
Yeah.
special edition because for those who didn't notice, we're going to be talking in English today. And Caio and Marcel will be talking about 5 things they've learned along this way of software development. So Caio,
Yeah.
Marcel, it's a pleasure to have you guys here. Thank you very much in the name of Competi for
Yeah.
making your time available for us and contributing to this environment, which is Cefet, the computer engineering course, and also Competi. So feel free to introduce yourselves, talk about your background, maybe your
Yeah.
English if you want to, and proceed to those 5 lessons we're going to learn today.
Thank you very
Awesome.
much.
Okay, thanks. Yeah, thank you very much. Today, I'll be mostly presenting those slides. Marcel might be talking every now and then in between. And as Davi just said, we'll be presenting 5 things that we learned along the way as software developers. I mean, we were born in Brazil, but most of our professional experiences and also my presentation experiences have been in English. So I would find it very difficult to do that in Portuguese. So I thought it's also an interesting learning experience for those who are here because in software, pretty much everything is in English. For this presentation, we're trying to break it down into maybe 3 or 4 parts. We're going to start with an introduction. I'll try to talk a little bit also software as a whole. I try to motivate or maybe give you some insight on how I see software, how we see software. And we're going to talk also about our backgrounds and then go into those 5 things. Starting with maybe an introduction. We already been introduced. My name is Caio. I'm 34 years old, and I'm currently a control software engineer at ASML. So ASML is a Dutch company. We're developing machines that produce microchips. So chances are, if you're working with, if you have like a smartphone or something, you have something to do with our products. And I do have more or less 10, I think about 11 years of professional software development experiences. I've been at ASML for about 1 year. I also have a master's degree in electrical engineering by UFMG in Belo Horizonte. And my major was embedded system design. And I have also a bachelor's degree in computer engineering by Unife, Universidade Federal de Itajubá. Maybe about Marcel?
Yeah, so I'm Marcel. I'm also 34 years old. Most of my experience is front-end software development. I'm also a front-end developer at ASML. So you can understand front-end as develop applications with web technologies mostly. I also studied computer engineering at Unife, and also have a master in electrical engineering at the university, but my major is a little bit different. I studied biomedical engineering.
Yeah.
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 Nowadays, I mostly work. That can go ahead. Just go ahead.
Sorry. Yeah. Okay, a little bit about my interests as well. As software developer, I'm mostly focused on low-level software developments. Well, nowadays is a little bit different. We're gonna get there, but I also enjoy a lot programming languages, compilers, and I'm very enthusiastic about agile practices. I'm not sure if you guys know about it, and I really like video games and languages. Maybe your interest, Marcel?
Yeah. So I think it's kind of natural if you work with front-end development, you're working with UI a lot. So one of my interests are user interface design, graphical design, all this kind of stuff that I haven't studied during my bachelor or something. I love graphic design. I love cooking. Also video games. I like Caio. Also, I love languages, and I love dachshunds. Do you know what dachshund is? It's a dog.
It's a breed of dog.
Sausage dog, you know, like
yeah, like a sausage, a very long dog.
I have one at home, so it's sleeping here. One of my
yeah. Yeah.
Yeah.
Professionally speaking, we have worked with a lot of, well, some of big companies. In Brazil, when we started working, actually, we had two years of work in Brazil, and we worked at this company in Campinas, São Paulo. I had the chance to work with IBM and HP there. And when I moved to the Netherlands, I had about 6 years of work experience with Philips. I also worked with a startup called Lightyear, where they were trying to develop a car that was moved by sunlight. Well, the company did not went that well, but it was a very good experience. And I was also working at ASML. For you, Marcel?
When I started my career, like Caio, I was also in Campinas. I worked 2 years for Motorola. There I was a camera engineer, so I was actually making tuning for cameras. It's kind of embedded software, but yeah, it's not really something that I was that interested in. And when I moved to the Netherlands, I joined EMAC. There I was working on front end. 4 years later, I joined TomTom. TomTom is a big Dutch company that makes maps like
like maps, whatever.
Like the Apple Maps are actual TomTom maps. So
yes, that's
I
true.
worked there for 1.5 years, and after that I joined ASML, and still there.
Yeah, we're currently there. So we're currently located in the south of the Netherlands, in a city called Eindhoven. You can see here in the picture, it's pretty much in the south. It's close to the border to Belgium, and it's a very nice place. It's about 200,000 people living here. And some people call this region as the Silicon Valley of Europe, and that's a good reason for that. Here's where Philips really started, and Philips back in the day was a really big company, and it spawned off a lot of other minor companies, which nowadays are huge companies, and it also attracted a lot of multinational companies to the region. And I mean, if there is a big company in the world, chances are there will be some representative here in this region. Also, there's some in Amsterdam, a little bit towards the north, but Eindhoven is a really good spot. We have also a picture here from the city center. You see there are some older buildings along with very modern buildings. The city is called like the Light City, also because Philips was started here. They produced light bulbs for a very long time. So a lot of things here go around Philips. And in the city center, you have some very interesting architecture. So if you go to the Netherlands, it's not the most touristic city to visit, but it's definitely a good place to spend some hours, and I really love this place. But I'm not here to talk about the Netherlands. We really want to talk about software as a whole, and I would like to start trying to inspire you guys about how what software means to me, and also what software has done to the world, right? I think if you stop to think about it, it's almost impossible to do something nowadays that doesn't have something to do with software, either directly or indirectly. So if you're walking down the streets and if you have your phone in your pockets, chances are you're doing something with software. Even if you have to cross the streets and there is a traffic lights there, software is involved. And it's really easy to take for granted how important software is in our daily lives. And when I was preparing this presentation, I was really thinking about it. And I tried to ask myself, how would life be without software as a whole, right? So, and if you take that instance, then you start realizing how much impact software has on our daily lives. And well, I did a quick Google search, and I find some interesting pictures of exactly 100 years ago, when software was not that prevalent. That actually was pretty much no software there. It was basically just this theory that was being developed. So I found this picture of 1924. So exactly, actually, it was from July, actually, exactly 100 years ago. And this is a woman building a telephone, which was the bleeding edge technology of the time. And it's interesting to see how humble and how rudimentary the whole thing looks like, right? So the telephone was basically a collection of electronic components and mechanics, and this was the best that they have. And it's, I mean, if you look at your smartphone nowadays, how much it can do, right? So what a big difference. And this is just the products part of it. I mean, telephone was really a big deal back in the day. But if you look at the service side of a telephone, what I found very interesting is that back in the day, you would require really human interaction to have the whole thing working, right? So this is not from the same time of the previous picture, but companies, telephone companies would have to organize this switchboard operator locations where a lot of people will be physically sitting there connecting your line to the line that you want to talk to. And actually, when you want to talk to someone, you would have actually to call those switchboard operators, ask them to connect you to a specific line, and they would have to physically do that. I mean, a lot of human interaction to see how many people are there. And that person has full control over your call. If that person decided that they want to disconnect you from the call, it would be able to. And even worse, that person would actually be able to listen to your whole entire private conversation, which is less than ideal, right? And nowadays, we don't really even imagine that you would require someone to physically connect your WhatsApp message from one side to the other. It's all done seamlessly in the background. And having software doing that for you frees up all those people to do something else, something more meaningful. And of course, they might have lost their job, but in the end, you're going to find something else that you can do that will help us out. And I find really this interesting. I find this very interesting picture. This is maybe a little bit earlier than the previous photo as well. This is what was something called the switchboard operator, so a person that you would talk to be able to connect your call from one side to the other. And it's really interesting to see how this is like a legacy from a time that doesn't exist anymore. We cannot even imagine that this was a profession back in the day. Thinking about computers then, I also found a very interesting picture about this computing division in the US. And again, you see like rows and rows of people doing some kind of manual work. Here they're using some kind of mechanical calculator. And what this photo is about people calculating salaries of people coming, of soldiers coming back from the First World War. And those people were required to manually enter the numbers, do all the calculations, fill in all the forms. And they are people, right? So they are prone to make mistakes, they get tired, and they're also required to be paid. So it's not a very efficient way, but that was the best they have back in the day. So with computers nowadays, your salary is basically calculated automatically. Here in the Netherlands, even your taxes are pretty much done automatically by a system. And again, all those people are just free to do something else. And it's really mind-blowing to me to think that this was reality. This was just normal 100 years ago, and how much computers and software has changed our society. To be fair, I cannot attribute all those changes to only software. Of course, electrical engineering, mechanics, chemistry, physics, mathematics, all have advanced a lot in the last 100 years, and everything together actually creates those new technologies. But I like to think of software as this binding tissue that brings everything together and allow those technologies to flourish. If you look at a smartphone, how much it changes our communication capabilities, how much it changes our entertainment, also in medicine, and now with the rise of artificial intelligence, software is again a very important, a very powerful changing agent in our society. I think the message I wanted to convey here is that software really unlocks an unprecedented progress in science and technology for human society. And it will probably continue to do that down the line, years down the line. And the picture that you see on the right side here is the first picture of a black hole. Maybe you guys saw that a few years ago. And it's a black hole called Nesta 87. It's about 5,000 light years away from Earth. And the funny thing about this is that for a very long time, physicists thought that black holes were just theoretical. They thought that they were just artifacts of the Einstein's equations and that they did not really exist. However, here we are. I mean, we managed to really take a picture of a black hole. And for this picture specifically, software played a very fundamental, a very crucial role to make it possible. Actually, without software, we will never be able to do that. But here we are. And just like those pioneers who managed to make this picture, you as a student, as the next generation, you are actually the next generation of these pioneers helping to push human progress ever further. And it's really powerful to realize that you can play a role to change our society, to make our world better. And it's everything in your fingertips. Like you can open your computer, you can literally create code, create software that can change the world. And it's really, really empowering and really interesting to notice that. As someone said before, of course, with great power comes also great responsibility. And it's really important to realize that you are, in many cases, you're most of the times responsible for the code that you deliver, and in many cases, you are even accountable for what you deliver. I mean, executing code has consequences also, not only for the machine, but also for the people around it, right? So you are responsible for what you deliver and what you work on. So that for that reason, working with quality and ethics should be your guiding principles at any moment. For sure, software makes lives much easier, right? So much better. Software can improve people's lives, but from the flip side, on the other side, it can really make lives much worse. It doesn't take much to go through a Google search and find a lot of situations where software has made people's lives considerably bad. And even if you think a few weeks ago, there was this CrowdStrike issue that caused a lot of problems in airports, in hospitals, in hotels, and whatnot. So it's important to realize that the code and the software that you're going to deliver, that you're going to work on in the future, has consequences on the real world, and you are also partially responsible for it. Well, it's pretty clear that I really like software. I mean, I would just would like to spend a few minutes discussing how we got into it. I mean, I'm really passionate about it, but how did it all begin? And to be honest, it was never the plan to become a software engineer. Not at all, actually. Ever since we were young, we always had something to do with computer. Our father gave us a computer when we were about 7 years old, and the picture that you see here is Windows 3.1. This was the first operating system we ever used. And back in the day, in the 90s, it was, well, nowadays it's very common to get kids playing with smartphones and computers and whatnot. But back in the day, in the 90s, was not that common. People would be playing around on the streets, but we actually preferred to be playing with computers and video games. And well, in the early 90s, that was the best that we have, and we actually really enjoyed it. And it also gave us actually some initial contact on software and computers as a whole. When we were about 14 years old, we got our first job as a web developer in a small business in our hometown. And one of the first programs that we used for that was Microsoft Front Page. Later on, we used other tools. But one very important thing that we got into back in the day was Flash, Micromedia Flash. Maybe you heard about it. Back in the day, it was a really, really big deal because it allowed for you to create very dynamic websites that were not possible with like just plain HTML. But nowadays, it's just an extinct technology. Like nobody talks about it anymore because it was also kind of a mess. But Flash was actually the first thing that opened my eyes for the possibilities of computers, how much you could do, how creative you could get with it. And in fact, actually, I learned to program with this, the programming language that Flash offered was ActionScript. The other thing that really got us into computers as a whole was video games in general. I always loved video games, and our original plan was actually to become game developers, but I'm glad that did not happen, because also as a software engineer, I can develop games if I want. But I mean, video games are just a different kind of computer, right? So that also felt very natural. So I'd say that throughout my entire life, I always had something to do with computers. So it just felt like natural step towards my professional career to study computer engineering and then start working with software. Thinking about that professional career and looking back 11 years from software development, I can really say that software provided me so many memorable and unique experiences that I don't think I would be able to have. Maybe I would have with some very specific careers, but I don't think I would be able to easily have those experiences if I was a lawyer, if I was a doctor or something. So I literally traveled around the world working with software, and I had the chance to work with very cool and very brilliant people along the way. We went to China, we went to the US, we went to Poland, all over the world, just working with software. And then we also had a chance to develop products that are literally in the hands of millions and millions of people. The picture that you see on the right side here is the latest machine from ASML. So this is a machine that produces microchips, basically, this what we call lithography machine. And this is the highest, the latest, greatest that we are producing. It's a high-NA EXE 5000. And we all have something to do with it. Of course, I work in a very small part of this, but indeed, in the end, my work is also there, and it's changing lives around the world. Some other minor projects that we'll work on was this device that you see on the top here from Philips. It's called a wake-up light. Here in the Netherlands, during the winter, the days are very short. So in the morning, it's actually pretty dark until almost 9 o'clock in the morning. So people use this device to kind of simulate the sunrise, like the sunlight coming into your room during the morning. And I was involved in some customer escalations, like helping people solve problems with the device, because I work on the software of this thing. And I literally talked to someone who told me that this device changed their lives during the winter. And that's really, really interesting to hear, because I spent a lot of effort to working on this product, and knowing that it has an impact on someone's lives was really, really interesting. Marcel also, when he was at Motorola, he worked on the cameras of those it was back when Motorola was part of Google. He worked on this Moto X and Moto G family of devices, and chances are, I mean, if you had one of those devices back in the day, you had something to do with his work as well. And I'm really inspired by that idea that software allows me to do this. Maybe another very important thing that software provided me, and is more personal thing, is that it allowed me to look at the world in a way more critical way. That also happens around the time I realized that this happened to me around the time I was at a master's degree, so there was completing my master's degree. That definitely has something to do with a university as a whole, but software really allowed me to look at the world in a more critical way. So especially when it comes to technology, I'm always trying to analyze how certain things are implemented, how I would tackle certain problems, and that opens your eyes for so many possibilities, and it's very interesting to see. Great. I mean, we have been discussing about the things that we've done, the things that software allows us to do, but it's also interesting to think about the things that we've learned through software, through our experiences. And the idea that we want to, I mean, software is quite diverse, right? And we could be talking about a lot of stuff, like how acronyms are used everywhere in software. And so in SML, I even have like my own abbreviation. People don't need to call me by my name. They just use a random abbreviation, and they know who we are just by that. Acronyms are everywhere. And we could also be talking about how you should never, never, never assume things in software. Just be sure, just take a look and make sure that whatever you're saying is correct. Because chances are, if you assume something, that thing will be incorrect or will be proven incorrect by someone. So never assume. Or we could also be talking about how software is always relative. Everything depends on software, especially in software architecture. There's never a right answer. Things are always relative. So those are minor things that you get over time, but we want to talk more about things that's, well, you guys are currently studying computer engineering. That means you're getting a lot of technical, theoretical knowledge. But we would like to discuss some things that you probably will not learn in a classroom. Those are things that you basically learn by doing, by experiencing software development, professional software development. And those are those kind things that we thought that would be interesting to share with you guys. And starting with the first one, which I guarantee you're gonna notice right away, is that software is a collaborative effort. What I mean by that, this picture tried to summarize it very well. It's pretty much everyone working together to deliver products. And the picture also summarizes very well. Some people are having a way harder time than others. And that's, well, in the end, it's all about we working together to achieve a certain goal. In that case, moving the boats through the water, it's just like that for software. And the reason why I say that software is a collaborative effort, it's because software is extremely complex, especially modern software nowadays. You require a lot of professionals with a lot of different expertises to fully realize this software. You require people who knows about UI UX design. You require people to work on front end and back end software. You require people for database, software testing, you name it. And even if you find someone who manages to, who is expert on every single aspect of software development, which I find very unlikely to find, it would take a very long time for one person to develop the whole thing. Because software is so complex and it requires so much, I mean, it has so many layers and it requires so much effort to be fully implemented. So it definitely will be implemented by multiple people in one team. And we're not even talking about stuff after you release your software, such as required maintenance or post-market surveillance to add new features or to adapt existing features. You have to, depending on the software, you have to provide software updates. So for one person to handle all of this is already really, really difficult. But if you're talking about software as a product, you also might require marketing, sales, customer support, HR management. It's pretty much impossible for one person to develop a full-scale software. And just as an illustration, I just did a quick Google search, and I looked for the number of people working on well-known software. And the first one I looked there was the Linux kernel. And by nature, this is a very collaborative thing because it's an open source project, so a lot of people working together to deliver something. And according to Google, there's about 16,000 software engineers or software developers contributing to this Linux kernel by itself. And on Google search itself, it takes about 60,000 software engineers, which is huge. And even for video games like Elden Ring, it took about 300 software developers to fully make it. So it's a very very diverse thing. You cannot imagine that those things would be developed by one person alone. And you are going to see it when you get to work with in a company. And I can almost 100% guarantee that you will be assigned to a team which will be working in a very small but fundamental part of the bigger software. Usually in large-scale software, the software itself is broken down into small subcomponents, which are then broken down into even smaller subcomponents, and then the teams are assigned to those subcomponents, and they are required to develop it, to maintain it over time. And bringing everything together, realize your full software. So it might feel that when you start working that you're not working on something very important, but in the end, without that small piece that you're working on, the software will never really exist. So it's important to realize that. It's not that it's not important, it's just that it's a small part of the whole picture. The other thing that you're going to notice, and well, I cannot guarantee that everywhere it will be like this, but most of the times teams are organized in a process called Scrum. I think maybe some of you probably have heard of it. But Scrum is like an agile framework. And being agile means that you are more or less prone to change. You don't plan in a very long scale like what waterfall would do. And the idea is that we try to provide value to our customers by creating small iterations of the products. And that's really true. What we do is every 2 weeks, basically, we spend time on planning and we start implementing a small part of the product, and then we deliver that part to our stakeholders, which might accept or not accept it. And that's how the development flow works with Scrum. Scrum also relies on what we call self-organized teams. That basically, it says that the teams are capable of managing themselves. You don't need a manager on top of the team to control every single step that they do. The team might be able to solve most of its problems, and if it doesn't, then it gets escalated. But self-organization is a really cornerstone of Scrum. And Scrum is really about flexibility because we assume that software is very complicated and it's prone to change. So we never try to plan for a very long time, but instead what we do is we do short iterations of about 2 to 4 weeks, and then we try to gather as much information as we can throughout this cycle to feed that back into our development flow so that we can improve it as we go. So it's more or less like you try to discover the environment as you move, because software can change at any moment. Another thing that I really like about Scrum is that it really encourages communication and openness. Scrum is about like it defines certain roles, defines certain meetings and certain deliverables, and most of the times it's set up in a way that you were encouraged to speak up and encouraged to be open about what's going on in the process so that you can actually improve and learn from your mistakes, which I find very interesting. I'm pretty much sure that you're going to work with Scrum at some point. And to be honest, I've never really worked in a team that did not implement some kind of Scrum somehow. Even small teams usually have some variants or very lightweight Scrum framework because that's a very good match with software. And here I meant that I say that software is complex, but I don't mean in the sense of the simple complexities, because software problems well, software is part of a problem type which is called complex. And being a complex problem means that there is no certainty. So there is no value in planning in the long term because things are expected to change. And Scrum is really a good match for those kind of problems. And that's the reason why it's overall in the industry. Great, so that brings us to the end of the first thing. So software is really a collaborative effort. So you're going to be working on teams. Great. The second thing that we figured out that might be interesting for you guys to keep in mind is that you should stay curious throughout your entire career. So as a software developer, software is extremely diverse. It changes very constantly. So it's very important to be curious throughout that journey. I do believe that being curious, or your curiosity as a whole, is probably your best tool to be exposed to new things, because I mean there is so much going on all the time that you will never be able to keep up with every single thing. So being curious really really allows you to center, to narrow down the things that really interest you, and it will also expose you to try new things, and through those new things you will be able to determine what you really like and what you don't like to work with. I see two ways how you usually try new things or get exposed to new things. And the first one is like personal motivations. I always think about my time at university when I was studying certain subjects, and there were very clearly things that I liked to study and things that I really did not like to study. And I spent some time doing this mental map of the things that I enjoyed during my time at Unife. And I really encourage you also to spend some time and think about the subjects and the things that really teases your curiosity and those things that you really don't like. For example, in my case, I really like things like programming languages, computer architecture, operating systems, and compilers. And I really did not like stuff like database management or even software engineering, like the theoretical side of it. I did not really enjoy it. But through my interests, like because I like computer architecture, I started getting in touch with some other computer architectures such as ARM, PowerPC, Z80, which naturally bring me to their assembly languages, which brings me to the compiler theory behind them, and that is inherently connected to lower level software developments. And this complex web of relationship between the things that I find interesting in the end guided me to the direction of being an embedded software developer, which was the thing that I really want to be. And I would say nowadays more or less my expertise. So my personal motivations here really guided me since the beginning, since when I was studying, guided me towards the career path that I'm right now. And I think it's important to be conscious about what you really like, even at that moment. The other way that you can experience new things is by your environment, especially when you join a new organization. Also, if you're doing a master's or a PhD, you will always be naturally be exposed to things that you're not aware of, and that the organization itself will force you, or not force you, but will require you to learn and to use. And some companies also try to use new and emerging technologies, or at least experiment with them. For example, AI is a big one. Every company is trying to do something with AI, so you're naturally exposed to those things. And people around you, like your friends, colleagues, and peers, might propose new things or expose you to new things that you are not aware of. Another example is this picture that you see on the side here. This is called Coco. It's a programming language and a framework that's used for creating control logic that can be mathematically verified. Basically, it creates a model that runs a lot of mathematical verification logic on it, so that you make sure that your control logic is good before you integrate that into your code base. After the model is done, then it will be converted into C++, and then you can integrate that into your product. The funny thing is that before I worked at SML, I never really thought of looking into it. I was never really interested on that. But when I started as SML, we were required to work on this, and I got a formal training. And I would say that nowadays, this is one of my favorite things to work with. And if I would only look at the embedded system background that I had, I would never really be interested in this and never really enjoy it. But the environment really provided me the chance to try it out, and I really liked it. So bottom line, two things. Use your curiosity to find your passion. That will definitely guide you for like the major strokes of your career path. Definitely guide you through the things that you like. But you should also remain open to new things, because you never know what could come across your path that could change things considerably, like what happened to me at SML. Of course, everything has two sides, so being curious is usually not enough, especially for software. And for that reason, you should be continuously learning about the things that really you are interested about. I noticed that after I started my professional career, and also as I started to get older, learning has become an increasingly passive activity for me. I spend rarely time on formally learning something through a book or through a course, aside from the things that I have to learn for SML, but by myself, I rarely do that. And most of the time, I'm just learning by doing something. If I want to try a new programming language, I usually just download the tools, start playing something, write a calculator or whatever, just to get the feeling of it. Or also you learn by looking at others or talking to your colleagues, but rarely formally. But there is definitely value on this formal education, especially for you guys who are starting, buying books, watching tutorials, watching videos about a specific topic, or even doing some specialization courses. Actually, that adds a lot of value, because it allows you to better master a tool or a technology or whatever, and also gives you like that background, like that's especially for your CV, it will add some visibility for you in the professional world. I'm mentioning that because it's difficult to say, but not difficult to say, but it's interesting to say that as a software engineer, you're never done learning, and that's might sound a little bit of cliche, but that's pretty much true. That's because software is so diverse; it changes so quickly that you need to be constantly updating yourself with the new trends and the new technologies. And for that reason, I'd say, if you have an interest, really try to learn that formally and dive into it. That brings us to the end of the second thing. The third thing, and I think this is probably one of the most important ones. We named it clean and tidy. And you see a picture of a very nice, organized room, but this is not really about your room. It's about your code. And well, before we go into that, I like to just think about code as code. I reflect a little bit about code. Code is an interesting thing because it's different than a puzzle. A puzzle usually has a single solution, but especially for programming problems, I'd say that there might be infinite ways to solve a specific problem, right? So each programmer will design a solution a little bit different than the other, and some of those solutions might be simpler than others. And the important thing to keep in mind on code and also on the way you program is that the code that you write, especially if you are in a company, is meant to be read by others, not only by a machine, not only by a compiler or by a computer. The code that you write will likely be in a code base for years down the line. And for that reason, you should write it in a way that it really saves people time, effort, and avoids confusion. Someone ever said that a good code make yours and others' lives easier, and that's pretty much true. I'm saying that because software is very flexible. I always found it interesting that when we were at university, some of our colleagues were studying electrical engineering or materials engineering, and every time they need to do something, they have to go to a lab, they need to prepare equipment. There is a lot of effort to start doing something. But software, I just need to open a laptop and I can start working. And for that reason, it's very easy to change software and to make changes to what you're doing. And also, as a consequence of that, it's really easy to take shortcuts and to leave some parts of the code to be fixed later, just because you don't have time and you don't want to touch that right now. And the problem is that if you keep on doing that and not having a structured way of working, things can quickly escalate into a mess, and you definitely lose control of your code base. I think the thing that I want to convey here is that, and the picture here on the side really tries to illustrate that well. we need to have this idea of cold hygiene, this concept of cold hygiene. And if you think of a doctor, do you think any doctor would ever operate someone without washing their hands? I find it very difficult. And doctors have also a lot of procedures, a lot of protocols that they need to follow in order to perform an operation. And I think we need, as software developers, need to have that mindset as well. We need to have a very structured and organized way of working, and like have a set of rules and habits that we do to properly write clean codes, organized codes, and code that can be maintained and understood in years down the line. It's important to keep in mind that each line of code that you write will be potentially read, especially if you're in a company, will potentially be read, changed, and most importantly, misunderstood by someone else. So the consequences of having that might be devastating for the company and for people around you. So having a structured, organized way of working is very crucial. Why I'm saying that is that when we were about 5 years down our professional careers, we got in touch with this Clean Code book from Robert T. Martin. And this book is basically a handbook about how to write software properly. And I have to say that this was one of those transformative things throughout my career. It really changed the way I look at my own codes and I look at others' codes as well. And the way the book presents it is a very raw and a very aggressive way. So it really points out all the mess, all the things that you're doing wrong, more or less. And it really felt like a reality check. It was something really visceral, if you will. This book is basically just a set of chapters that tries to propose certain ideas how to write better code, like how to improve naming, how to improve comments, how to apply certain design patterns or idioms, or certain rules for coding style. And it also proposes some very radical ideas, such as functions should only have 5 lines of code at most. And if you look at internet, there are a lot of controversial ideas. Some people really love this, some people really hate it. And it's up to you to decide, but for me, it was really like this reality check that really caught my attention. If you ask me now if those advices in this book are good, actually I would say absolutely yes, for sure. The ideas here are really solid, they're really important, and it brings that idea of cold hygiene into the forefront. But if you ask me if we should apply those ideas blindly everywhere, I would say absolutely not, because everything in software is a trade-off, and applying certain concepts from this book blindly might actually have very severe consequences on your software. For example, I was an embedded software engineer, I still kind of embedded software engineer, and using this idea of 5 lines of code per function has a very deep impact on the stack size, on code size, and also on performance. So I cannot just blindly apply those ideas, and otherwise I will have very bad consequences on my software. So for that reason, I try to see this book as more or less a mindset shifting tool. So it's something that you can use, and I really recommend you guys to take a look at it. There is also some video lessons from this guy that follows actually the entire book. So I really recommend you to spend some time with this, and maybe you already saw it, but I like to think of it as indeed a mindset shifting tool. It's something that you should not apply blindly, dogmatically on your code base, but should be like in case by case. So you really need to understand what are the consequences of that. But having this mindset of writing code in the proper way so that it will be reusable, maintainable over time, is maybe the most important aspect of the book. Well, that brings us to the fourth thing that we find very interesting. And up to now, we've been talking very passionate about software and about all the good things and all the things that we can learn and do better. But also, there's always another side on it, and especially on game development nowadays. Software has some growing pains, if you will. In the modern society, and actually in the modern industry, things tend to go faster and faster over time. And for software, it's even worse because the software industry as a whole is very dynamic. Things change in a steady pace very quickly. So companies really try to catch up to other companies, and they kind of push developers to do more and more with less and less time and less resources, which over time sets a lot of pressure over developers. And that can get really worse during some crucial moments during software development time, like during the deployment moments, during integration moments, during release times. And for those who are involved in those events, those moments, the companies kind of expect that the developer will have some extra pressure on them. Pressure means working extra hours, basically. And that's really bad for those mission critical software that cannot stop at all. Like if you stop something, people might die, or the company might lose a lot of money. So the companies kind of expects that you will be doing that. And that can really leads to some long days and especially some long nights. And I have to say, also by my choice, not by companies, only by the companies. I've been there several times, and I have to say, by SML, actually things are pretty okay. But in other previous experiences, I had to work some very long hours. The thing is, the companies really need to realize that these have some impacts on the developers, like experiencing this chronic workspace stress. Like you're expected to do more and more with less and less, and you have to work a lot, like a high workload, and having this poor work-life balance, especially if you work long hours and have very little time for yourself, can definitely lead to decreased productivity, less motivation over time. You might feel less interested and less satisfied with your job, might want to change jobs, for example. And in the worst case scenario, it might lead even to a burnout, which has very bad consequences for you and for the people around you. But it not only affects the developers, but also the products that the companies are working on. This picture really summarizes that. You can take a look at that later. But on the products on the long term, if you're always in this firefighting mode of always doing more and more with less and less time, the code base as a whole will start to degrade in terms of quality, because you're never doing things properly. You're always just doing the bare minimum to just ship whatever they want and do that as fast as possible. So you're not doing things properly, so quality will definitely degrade. And technical debt will continuously increase over time because you never have time to fix things. You're just always constantly being pushed to do more and more. And for that reason, it also increases the chance of regression. Regression is basically bugs on things that were already working. So if you don't test things properly, or if you just take shortcuts, the likelihood increases considerably, and also the creation of new bugs also increases considerably. I think what we want to try to convey to you guys is that you should protect yourself. So you should be able to set your own boundaries. And one of the best ways to do that is to do your own homework. By homework, I mean, first off, it's better for you to understand what really works for you. So how much pressure can you take, right, in your work environment? And also, how much pressure are you expecting to take when you stop working? It's also very important to keep in mind that to try to understand what kind of work-life balance you want. So if you want to work for a big tech company in the US, for example, the pressure there is definitely different than the pressure that you would experience by a company in your hometown, for example. So it's better to understand what are your ambitions and where you want to get to, even before you apply to any company. When you're applying to the company, especially during your interview process, it's really good to ask certain questions so that you understand how things go, how much pressure you're expected to take on the environment. Like you can ask how many hours does the team typically works, how big the team is, how big is the company as well, and most importantly, what kind of work are you expected to be doing in a company. If you're supposed to work on integration or customer support, definitely it's way more pressure than working with, I don't know, developing a new UI for the software. So you need to understand what you're going to do to understand the impact on you later on. If everything goes okay and you don't find any red flags during the interview process, you might be working for a company. So when you're there, it's also important that you do your homework. And the first thing that I think you should be doing is to set your priorities. So make sure that you're working on the things that really matter. So I guarantee you, when you're working, there will be a lot of requests coming from a lot of people that have nothing to do with your job. And if you keep on doing those things, over time, they will add up. And the things that really matter are still there to be developed. So you will be probably doing extra hours because you're just working on the wrong things. It's also important to make sure that you and the other people around you understand what are your roles and responsibilities, so that those weird requests don't come to you. And maybe it might sound a little bit unrelated, but working transparently and sharing knowledge within your team also helps a lot. Because in the case that you are sick or that you cannot take the loads or you're too pressured, there is always someone else in your team that can back you up. So being transparent and working with people really helps to set your limits and also have a better work-life balance. Unfortunately, sometimes you will not be able to avoid extra work. So you will be, because there is a problem, because the company really needs, you'll be doing some extra work. And as software developers, we have the responsibility to, we might feel responsible to do the expected work, right? But it's also important that you also look for compensation afterwards. Either you take extra hours, if you work like, I don't know, 10 hours a day, then the next day you take 2 hours off just to compensate for that, or try to get some compensation in terms of salary or whatever. It's also important to keep a very fair and open conversation with your manager so that you ensure that this extra work that you're doing is not the rule, but actually the exception, right? So make sure that this does not become the norm in your workplace. And of course, you are working on a team, so it's a good idea to spread the load among your teammates so everybody feels a little bit, but not, doesn't feel that much if you will be carrying everything by yourself. Those are big things that you can do in the workplace, but also minor things can help you improve the work-life balance, like taking regular breaks. Usually when you're working, especially in a complex software problem, you might be working 6-7 hours non-stop on a problem. So it's good to take a break, walk around, just go outside, get some fresh air. Try to keep things fresh by doing something else when you're not working, like go to swim or play with, video games, or do something different. Stay away from the computer for a while. Changing the workspace, like changing the location of the furniture or changing your desk a little bit, always helps get things a little bit fresh. And try to get adequate amounts of sleep, and be careful with coffee as well. And most importantly, stay alert for stress and extra pressure that you feel throughout your work hours. Like your body's really good at giving you signs, so it's good to be alert so that you avoid bigger problems down the line. Great, that brings us to the last advice. And well, that's very simple. There's not much to it. I really wish that you have fun down your professional career. For me, it still takes 33 years to be retired. So I'll be working with software for quite a long time. And I think it's really important to keep things fun in order to keep it, well, interesting over this long period, right? And I think software development is pretty much what this picture shows. It's like a roller coaster, right? It has ups and downs, but overall ride is really fun. And I hope that when you get starting with software and you get start working professionally, that you feel the same thrill that I feel with software as being a software developer. And that brings us to the end of this presentation. I'd like to thank you guys for your time, and it was really fun to spend some time with you today. That's it. If you guys have any questions, I don't know if we can talk. I don't know. You can also try to contact us if you need.
Davi, you're mute. Oh, I think you're mute, Davi.
Thank you. So I was saying that, yes, we have some questions. Me, myself, I have some questions. And you both can answer in your own ways. So I'll take the questions here and I will contextualize on or just read. Wait, are you guys seeing me?
Yeah, I guess. Yeah.
Actually, I cannot see it, but what I can do is I can stop presenting then. And then probably I can read something. Okay.
Okay, they're saying that it's fine. My camera is working. So I'll start with the first question, which is, let me check. How did you guys learn English and the local language, and how important it was to your career? So we spoke about it, so you would basically repeat it, right?
Yeah, so I have to say, for software, English is really fundamental. I think you probably see even in programming languages, the textbooks that you guys use, it's mostly in English. So English is really, I think, fundamental for you. in our case, we never really learned English formally. Of course, you learn at a school, primary school and high school, but I never really follow any course. So it's more like by being in touch with media in English, like watching television, reading articles, playing video games in English as well, and yeah, just like living the language more or less. The same applied for Dutch, the language in the Netherlands. We had very little formal education on Dutch, but we listen to the radio, we talk to people, and through that interaction, you will definitely learn the language. And as a software engineer, regardless where you are, English is the key for sure.
At least for can you hear me? I think so.
Yeah.
Yes, we can.
So at least for me, my experience with Dutch, I think the most important thing, if you're living in a country like the Netherlands, where you don't have like the people can speak English, but it's not a native language. Just try to make new friends in that that are native to that language, and try to talk to them, and don't be shy. Yeah? They will understand that you're trying. This is like the recipe that for us at least works, and yeah, just leave the language. Like the English, or if you want to speak Spanish, whatever. Just leave the language. Change your phone to the to the language that you want to learn. Everything. Just leave it. So it come naturally.
Yeah, sometimes we don't give value to the small efforts, but studying in a college, in a heavy course, I'd say yes, computer engineering, it's very hard to, I don't know, study English for 2 or 3 hours daily. So we should really focus on this small efforts, because we have 5 years at least ahead, so it would pay off in the end.
Definitely. I definitely agree with what you said, for sure. Yeah.
Another question that we have and would like to know is that between you two, we have 20 years of experience in software development. So we'd like to know what areas, beyond yours, of course, do you see as promising? Because we have the trending areas. At least in Brazil, we have web development. But let's suppose, for example, that your son, your kid, get you and say, "Daddy, I don't like what you do. I want another career path. What would you recommend me?"
So it depends on where you are. I mean, if you're in Asia, for example, embedded software is definitely something that you can consider. That's what I studied. But I think most of the times, system programming is very, 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 very important. So I worked at Philips at medical devices, and basically they use like C# and C++. So system development is one. I mean, you always need something to be the back end of your technology. So I think that's definitely one big one. But I think web is definitely the biggest one. Also mobile, like iOS development, Android development is definitely one of the biggest ones. Yeah.
One thing that I also find very, very important is how can I say that? The data engineering, let's say, data is everything today, right? If you have data, you have the world. So having at least a little bit of knowledge of
data science,
and this is something that AI is basically data, if you think about it. And if AI is that big today, it's because we have a lot of data nowadays. So for sure, just try to learn a little bit of data science, or understanding those concepts. This is already big today and will be bigger in the future. So
I think another safe bet is probably DevOps. I mean, especially for infrastructure work, they will always be needed. So having some knowledge there also helps a lot, especially for big companies. We study with 40 people. I know a lot of people that study with us that work with DevOps in the end. So that's also another option.
All right.
Don't go to video game development. It's really apparently it's really hard. I mean, people are really pushed to the limits there. So I would not recommend that.
People are what? Sorry, I didn't hear it.
People are really pushed to the limits. Are really, I mean, squeezed down to the bones. They say that the culture, video game development culture, is quite exactly. So I would not recommend that.
Yeah, I didn't know that. That's interesting to know. Yeah. Well, another question that we have here in our chat is from Indiara. She said, how can developers stay updated with the latest trends and technologies in software development? Are there any correct ways to search, like social networks, for example? Well, I think that's a reasonable question because nowadays, I mean, if we don't have enough time, it's hard to seek for information. So how do you guys stay updated?
Well, there are two things. I think because there's so much going on, it's important to narrow down what you want to focus. For example, I really want to come to follow the software architecture career path at some point. So I subscribe. There's a very good website that's all about software architecture. So I subscribe to their newsletter, and every month I get a summary of what are the trending topics. So especially on internet, I would probably read a lot and also listen to a lot of podcasts related to software as a whole. So people will be, I follow like a C++ podcast, and C++ is constantly also changing. There's always something new popping up. So every week there will be something that they will be talking about that I have never heard about. And I mean, it's unfortunately it's actively looking for certain sources that might give you that information, but filter them out. Otherwise, it's just too much information for you. Just, I mean, do your homework, look for sources that you might find interesting, and constantly use those sources. Right, like what I said, I have the podcast, I have the newsletter, and those things are the inflow of information for me.
Yeah, I
Marcel,
think
any contribution?
I think it just had everything, and I also like in the presentation, Caio said, just stay curious. If you have interest in that, just seek for information and keep looking for it. So
I think for me at least, if I force myself to look for it, it gets less enjoyable. So I try to do it in a more organic way. So like I naturally will, if I open a website that's all about software architecture, I'll naturally get more in touch with what's going on, right? So don't force it, and try to get contact with the things that you're interested with.
Yeah. Well, you said about the newsletter and podcast, and I see that they are two very different options and very interesting options because the newsletter is something that is more objective. But I feel like when you watch podcasts or you listen to podcasts, you are seeing things in a more personal way because when you read a newsletter, you read something, but you don't really know what's going on, what's the
Yeah, I
climate, you know. But when you
Yeah.
watch a podcast, you know how guys are feeling about something because
Yeah.
they express it. So I really feel like
Emotion.
podcast is a very good way of learning and staying updated.
Absolutely.
For sure, yeah. And there's also a lot of podcasts that's just tutorials, right? So they just explain the technology. And I mean, some podcasts is also about people's experience, like what we did here. There are podcasts about people who were software architects for 10 years, I don't know. So there's a lot of options, and I think podcasts are also indeed a very good option.
Yes, I feel like the problem today is the excess of information because once people have a lot of information, they don't know where to focus. So when you have
Yeah.
everything, you have nothing. If everybody's a
Yeah,
friend,
exactly.
nobody's a friend. This concept.
Yeah.
So I think maybe it's important to, as you said, find something and stick to it. I like this guy. I trust this guy, so I follow this
Yeah.
guy. If someday he doesn't, I don't feel like I should trust him anymore. I'll find another one, but I won't
Yeah.
care about other information. I can read something, but I'll stick to this guy. Why not?
Yes. Yeah,
Um,
exactly.
so let's go to another question. And I think that's very interesting because
Mm.
we're talking about um, coding and software development. And well, at least when we are younger, we imagine coders as hackers. You know, they're in the basement coding with green, that green letters. But how
Yeah.
do you see, or how do you see that the
Oh man.
social skills play a role in your software
Oh.
development path? Because me myself, I see that shy people, they lose a lot. They can't even conceive how much they lose. So how would you say that
I
this happened over your lives?
I fully agree. I mean, I mentioned that. I mean, there was the first thing I mentioned in the presentation that software is a collaborative effort because we expect that you're going to be working together with people. And I think, especially the way teams are organized nowadays, really encourage you to be part of a team, to be part of a community. So, of course, you don't need to be the most how to say, most dynamic person in the world, but having some communication skills and having to being able to talk to people, align about certain things, and being open about the problems that you face is really fundamental. Software engineers can be introverts, no problem. It can be extrovert as well. But what it really requires is being able to speak up and to talk to people, right? I mean, you don't need to be scared of people. You just talk to them, and you don't need to be like partying with them all the time and going going out with them every single day. But also, I mean, my team, every now and then we have also those team events where we all go together, do something. So I think that idea that software engineers are just like stuck in a room doing, it's not really true. I mean, those are just normal people, very social people most of the time.
I also think that something that's very important, like a soft skill for software engineers, really to know, to be very transparent about what you're doing and make sure that everybody understands what's going on, because it's very easy to have miscommunication, and miscommunication can cost a lot of money. And I'm experiencing this right now with in my project. So just make sure that if you're doing something, if you how can I say that? If you say that you're going to deliver something at that time or at that date, please do it, because alignment is key in software development, really.
Yeah, and again, you don't need to be an you don't need to be an extrovert to do that alignment. So
everybody can make sure that everything's aligned. If you're doing something, just make sure that everybody that's depending on that knows that what's the status of it. So yeah.
Yes, I think we could even put it inside number 4, that is know your limits. Because me personally, I passed through something related to this, because we had a striking in Brazil, the federal universities. So we were like 3 years off. No, not 3 years. Sorry, 3 months off. And over these 3 months, I was fine. I was studying, waking up early, doing my things. But when I returned, I realized that I was with a lot of headaches. Then I was wondering, what is this? What are those headaches? What is the problem? Is that, people? Is that my eyes? So I realized that maybe I was spending too much energy with people, because I see that naturally I am an introverted, but I learned to speak because I know it's useful. But even though I learned to speak, I have to know my limits and understand that I cannot spend all my energy with everybody. And so I'm learning with me. And well, if you're going to go 10 years, 20 years into this profession, I think that it's important to know yourself.
Absolutely.
For sure. Yeah, absolutely. Really good points. Yeah, for sure. I fully agree with that.
All right, so let's go for the next question. And the next question is from João, it seems, João Guimarães. What tip do you guys think that is most important to write clean code?
Again, software is meant to be. Sorry, go ahead.
Just go ahead. Just go ahead.
So software is really meant to be. I mean, especially in a big company, if you write a line of code today, it's probably going to be there for maybe. I mean, depends on the company. So as ML, we write. I maintain code that has been written 25 years ago. So, I mean, if you don't have a very well organized, a very clear way of writing your software, those who are going to change them might have a very bad time understanding what you meant and can make a lot of mistakes. So, being very careful with your coding as a whole, your coding style, your coding practices really help to maintain your code base over time. Otherwise, it will be unmanageable. So, I heard of stories that certain companies have to restart the software from scratch because they simply could not maintain the mass of their code base. And it costs a lot of money and a lot of effort. So, yeah.
I think if I have to give a tip about what should, like, at least if you haven't read the book, like, if I have to choose 2 things they said there, is like choose very well your names, like name of variables, name of classes, name of functions. They have to be like if you for function doing something, the name should be really clear that function does that. And the second one is to try to write small functions. This cannot be applied for everything, like Caio said. For embedded software, small functions can be a nightmare. But like if you're developing something in front end or something like a React application, whatever, this can be very much applied. And small functions that do one thing and very well, that one thing, that helps a lot of cleaning up your code. So two things: choose right names and make small functions. That's basically.
And about the functions, they say that the function needs to be small because if the function only does one thing, you have way less room to do it incorrectly or to understand it incorrectly. So the names together with the small functions really create like this a better coding approach.
And also, if a function is small, it's very easy to be tested. So
yeah, that's true. Yeah, that's
focus
correct.
on that.
Yeah.
First thing,
Yeah.
choose good names. Never add like if you have two variables, I don't know, x and x2. These are terrible names. So choose writer names.
Yeah, but they say that the code, at least the code that you're writing, should be very expressive. So it needs to convey clearly what the code is supposed to do. So that's why the names, sometimes I write functions that have a very long name, but it actually describes precisely what the function is doing. And this book also says that the code should be written almost like a story. If you go from top to bottom, it should read more or less like normal language. So it's, that's something
to make a lot of difference to code quality for sure.
Yeah, for sure.
Yeah, this is really a great combo. This names and the functions, small functions. I never really thought about it. I didn't really know this, but those small functions thing are really implemented. Me myself, I really use it.
Yeah.
So we're talking about books. So I like to know if you guys have any other books recommendations.
So from the same author, there is this clean architecture book that also shows, but it's a little bit more higher level. Here it's really about the code that you're writing. Clean architecture is about how you design software as a whole, like how you interact components in your software, how to make sure that they are they apply this single responsibility principle. So each component is responsible for one functionality in your software. So it's like I'd say a continuation of this clean code. So I would definitely recommend that one. Another book that I read, but that's also very specific, is especially if you're working on C++, I would definitely recommend you to read about the standard library and the language standard. I read C++ 17, and C++ is a very powerful but very dangerous language. It's very easy to shoot yourself in the foot if you don't know what you're doing. So for those cases, especially for C++, reads the official documentation and reads. There's a lot of books explaining the standard library, explaining the language standard. Try to read that and get as much out of those books. And you have also, probably you guys also have those general algorithms books that are, I forgot the name of the book, I try to remember. But general things that you would use at university, would still be applicable even when you're studying. So, yeah. I don't know if you have any, Marcel.
Yeah, for me, I don't have like a software recommendation. As I mentioned, I don't think I mentioned that, but I'm working now with UX design at my current role. So I'm reading this book. It's more like for UX designers, but I think there's also value for software developers. Basically, what this book tries to teach us is how the world is like designed and how should we take decisions on when designing something like a UI for application to make it like more human and easy to use. And I think it also can be applied to software somehow. I'm still reading it, but it's very interesting. So maybe for someone, I'm not sure if you can read it.
All right. Yes, that was clear. So the next question is about health, and I think that even though that's a simple question, it's reasonable because sometimes you're not doctors, but sometimes we just take things seriously when we hear from someone that we see ourselves in the person. So like I don't know if my mom says something to me, I won't listen, but if Woodpecker says, I will listen.
Yeah,
so people want to listen from you and your experience. So what are some tips for a better mental and physical health?
Yeah, that's a very good one. So, as a software developer, I have to say that I usually stick too much to my work. I like if I'm working on a software problem. Usually, I'm there working for hours, and I can very easily overwork myself. But I try to counterbalance that by doing two things. So the first one is we go to the gym pretty much every day. So try to do some physical exercise so that you also change your environment and also get some energy. So we do that very early in the morning normally. So about 6 o'clock in the morning. So try to get some physical exercise. It really helps you. And about mental health as a whole, I mean, especially, well, I've been there several times, but if you start feeling very tired, or if you're feeling that you don't have, you don't want to do things outside of your work, like you're at home, and if you just want to sit in front of TV and doing nothing, that's probably a sign that you're either overworked or a little bit stressed. So pay attention to those things. I mean, even if you start feeling a little bit depressed, I don't know, that's probably a consequence of this extra work that you're doing. And I'll definitely say I need to learn that myself. I usually work, and my manager actually contacted me several times because I'm doing too much extra hours. But I mean, that's something I'm learning. But I'm aware of the signs of my body, and yeah, I try to compensate that somehow. Yeah.
I'm kind of the opposite. I try not to do that. So, yeah.
Yeah.
No,
But
here in the
it's
Netherlands,
really,
it's possible to do because they respect a lot of your personal time. So
yeah, that's
if
true.
they pay
That's
you to
true.
work like from 8, I don't know, 8 to 5, sometimes, most of the times, they don't expect you to overwork. So, and I follow
Not at
that.
all. And to be honest, we don't even get extra pay for extra
Yeah,
work
there's no
hours. You just
extra
have like
pay,
a
extra
you
hours.
just
Like,
get like
what?
some extra hours that you can take off later on, but you don't get money from them. If you're working extra, it's all on you. So the company don't expect you to do that at all. But it's case by case. But definitely, if you feel that, especially for me, I mean, sometimes when I'm very tired, I feel like I can sleep anywhere. That's probably not a good sign because I'm definitely very tired, very mentally exhausted.
So
I mean, I'm no
I think
doctor, but that's how I feel.
I think I think the most important thing for me is like uh, just try to prioritize not your work but your life. Uh,
Yeah,
your
yeah,
work
only
is
live
very
once.
important, but I think that yeah, we do work for some reason, for to get money and to leave, whatever. But you also have a life outside of it, and don't let the life of work just consume your life outside of work. So that's
Yeah,
basically what I do. So yeah,
Well, and
yeah,
something that I personally would like to know, because that's something recent in my life, is related to environment. And I think that you spoke about it briefly on number
yeah,
4 when you were talking about know your limits. I think you said try to go to the office or something like that. And
yeah,
I'm not really sure if that's the thing. Maybe it is on number 4. Yeah. So
yeah, it is.
I
Yeah,
I recently discovered that for me to be efficient and to do the things I have to do, I have to get out of my house and I have to go somewhere else, and I
hmm
had
yes,
to have a good sleep schedule. So I'm always
yeah.
trying to sleep early and sleep well. So what do you guys have to say about the environment? Because some people work well, work in home office, but what is your case personally of you
I,
guys?
I, I think we're kind of different. Marcel is completely
so,
different than me. So I get
yeah,
a lot of energy going to work in the office. I love talking to people, seeing people around. That gives me a lot of energy. Of course, in the Netherlands, especially at SML right now, you can work more or less 2 to 3 days from home, and then the other days you have to go to the office. And if I would have to choose, I would go to the office every single day because just it gives me more energy. Also, switching context, like not being sitting in this desk for 8 hours a day for me is like much better. I like to go to the office. I think Marcel is completely the opposite.
for me, I find really inefficient to go to have to bike to the office and stay there and moving between rooms for meetings. I find it really inefficient. I work much better at home. So what I'm doing now is like I go to the office once a week. So basically, when we have like I don't know if you're familiar with the Scrum stuff. So but then if you have like refinements and these meetings that are kind of nice to have people around live in the same place. So I go. We have like at Thursday we have those meetings, so I go there. But most of the time I stay at home because I work much better, much efficienter.
Yeah,
I don't know. For
it's
me, it works like that.
Yeah, it's a case by case thing, but it depends on what kind of person you are. For me, definitely go to the office at least sometimes to change your environment. Marcel, in the end, also always goes to the office. It's also expected that you will go there, but yeah, it's you need to find out what works better for you. Yeah,
Yeah. And if you're like in a company that does not like force you to go to the office, and that's nice, but you have to find your balance also. I think.
yeah,
Yeah, I think that the final answer is don't lie to yourself because if you are not Marcel, don't try to be Marcel. Maybe
yes, yeah, good one.
just maybe you are just lazy and you want to stay home.
Yeah, exactly.
That's
Yeah.
true. That's true. Yeah, yeah. I mean, find what works better for you, and don't push it. Right. So that's it.
Yes. So another question that we have here: do you guys have any profile of person that maybe just maybe is not fit for software development? Maybe this kind of person that I like software development. Oh, then you see the person and you look like no, I don't think you like. I don't think you're fit for that.
Oh man, that's a good question.
Mm,
Okay, so I'd say, well, we have another brother, and our brother always had a very hard time. He studied what we call what is the name? Computer systems. So it's not computer engineering, but it's more like a programming focused course. And it was a really struggle for him to get through the entire course, like all the 5 years. So that's already more or less a good sign of that. And if you see that a person doesn't get energy from the kind of problems that arise from software development, that's probably like a sign that that person's not, I mean, not suitable or not suitable. It doesn't match that person's profile. And our brother is now trying to become a manager. He's really going the path down a management career, and that's also a good indication. But aside from that, most of the times, well, I think I cannot think of a person that I worked on that it's not really suitable for software. I just know my brother because I know him better, or older brother because I know him better. But yeah, that's a good question. I think if the person doesn't get much energy of software in general, that's probably an indication that it's not suitable for him.
I think if you don't like programming and if you're not curious about this stuff, you're probably not going to be a very, very good software
Yeah,
developer.
yeah. As we mentioned, software is constantly changing, so you need to be chasing it as well, right? So if you don't feel like to do that, probably, I mean, you're going to be lagging behind. So yeah,
Yeah.
I yeah, I think that yeah,
It's a very good
that's a
question,
good
but I have to
indication.
think about it, to be honest.
Yeah,
Yeah,
for sure. Yeah,
never
for
thought
sure.
about it.
Yeah.
Never thought about
So it leads us to another question, which is,
Mm.
what do you guys, you guys think about the phrase? I think that it is do love what you do and you never work again. I mean,
Oh, that's
the relation between what you do and your vocation or your passion.
to be honest, I would never choose anything else than software. I really love it, but it still feels like a job. I mean, I do my own projects that also related to software, but I mean the dynamics, the pressure, is definitely different than just working with a passion product, right? So you're still working; it's still business, right? I find it very difficult to believe that there is this thing that if you do what you love, you don't even feel like you're working because there will always be situations where things are not going well and there will be some pressure coming from other people or from the company. So yeah, I find it very difficult to believe that this is true or that even exists. At least for me, it doesn't exist.
it. Yeah, and I, yeah, I also, yeah, you could give a good answer for that. I actually forgot what I want to say. I was thinking about something.
I was waiting for Marcel
Yeah,
a different answer, like the home office thing.
same.
I thought he would say something like, "No, you know what? I really love what I do. If it was for free, I would still do it. I don't feel like I'm working."
So
No, I still,
I also think that this is probably not true,
yeah,
because yeah, as soon as your work has something to do with money, there will be pressure for sure.
yeah,
And yeah, like I said, like there's moments that are not be going very well, and I highly doubt that always be like roses, and I don't know, don't think so.
yeah, for sure not.
Yeah.
Yeah.
I,
So,
I mean, yeah. No,
so
go ahead.
please
Sorry.
keep going.
I mean, I really think about the software. I mean, a lot during my day, so I really like it. But I cannot. I have a clear separation of things that I do in my work and the things that I do like for my own entertainments, like my own projects or whatever. So I think there will always be this clear cut between what is software, what is professional, and what's personal, and what is passion,
Professional.
right?
Yeah.
Yeah.
Then if you're doing something for yourself, then it's kind of like a passion thing because you decide your stuff and you guide your stuff. You have your own tempo, and yeah, then maybe it's more passionate. But like saying that I have a passion working with software, I will never actually work again. That's not true.
I don't think it's true. No.
All right. Well, 10, 20 years of experience, so I think we have some. I think we should believe it, right? So the very, very, very last question. Well, that's a very
Yeah.
objective question, but what's the slide software you're using?
Oh, it's called
Apple.
Keynote. It's from Apple. Let me see. I cannot show it, but it's called Keynote. Let me see.
If you have an
Over
iCloud
here.
account, you can also use
This
it in the
thing.
browser.
Oh, right.
Yeah.
Yeah. I've
Yeah,
seen that before,
so
but
it's-
I really never used it.
Mm.
Yeah, it's pretty good.
That is-
But if you're used
To
to
be honest-
PowerPoint, it can be annoying. Yeah.
Is that the user experience is completely different from PowerPoint, so you're going to be a lot lost there. So
Yeah.
But
at
this
the
is a
beginning
nice
it's really
software.
annoying,
Very nice.
but it's
It's a-
really nice.
Yeah, it's like a difficult learning curve, let's say, but it's a nice software. It's a better option than PowerPoint.
Yeah, I think so. Yeah. But that's it. Yeah.
All right. So I think that it seems like that's it for today. I like again to thank you, Caio and Marcel, in name of
Yeah.
Safety and Competi for making your time available for us. It was really useful. I can say by myself, I think that the people that are watching us would agree with me. And we really hope, me personally, I really hope to have the chance to interview you guys again in the near future. I don't know, maybe 1 year, 2 years. Let's see. And if you
Yeah,
guys
for
have a
sure.
final message for the people that are watching us.
Well, I really enjoyed the time here. I also like the questions quite a lot. And again, I mean, I love software and I want you guys also to feel that passion. So that's why I also decided to do this. So keep curious, keep on enjoying what you're learning, and be prepared for what's to come because it's going to be a really fun ride.
And I also, just to add a little bit to what, I hope you guys learned something from what we said today. This is based on our experience. Of course, everybody has a different experience, but this is in general when you're in the markets, what you're going to experience and what we think that you can have a better career on that. So
Yeah. Thanks for the opportunity. I really enjoy it. Yeah.
Thank you very much.
Yes, we thank you, and I would like to thank you guys that are watching us. Thank you for your. I don't know how to say this word in English, and I think I forgot this in Portuguese. But thank you for watching us, and I see you in the next COMPET Talks. Bye, guys.
Great. See you guys. Bye.